Morning everyone. Today we are going to see an interesting lesson called solutions. Before we go into the lesson solutions, I hope you have learned in your lower classes about mixtures. What is a mixture? And we are going to see two kinds of mixtures today. One is homogeneous mixture and the other one is the heterogeneous mixture. I'll demonstrate to you a simple experiment. I've got two glasses of water. I have salt. On the other hand, I have mud. What I'm going to do is I'm going to take a small amount of salt, put it in the water and stir it up. Fine. I'll take the other spoon, take some amount of mud or sand and stir it up. Dear children, you can see very well the salt got dissolved in the water, and here the mud, it forms a layer. There are two layers and the mud is not dissolved in water. So this, I call it as a homogeneous mixture, and this I call it as a heterogeneous mixture. Yes, my dear students, now we are going to see about the components of solution. And we have already seen that a solution consists of two components, isn't it? Now we are going to see what are the two components. I have a glass with me. I am pouring water into it. Water is almost full. Again, I have salt with me. A small amount of salt is taken, dropped in the water, and I stir it up. Yes, you can see very well what happened to the salt. The salt got completely dissolved in the water. Otherwise, I'll put it this way. Salt got distributed in the water completely. And now I'm going to explain three terms to you. The first term is, better ask a question to you. Which component is present in the lesser amount? Yes, someone is saying salt. Yes, salt is present in lesser amount. And which is present in the larger amount? Water. Fine. Water is present in larger amount. Now, the substance which is present in lesser amount and which is dissolved in the solvent is called as the solute. The substance which is present in larger amount is called as the solvent. Together, salt plus water, that is solute plus water, is called as the solution. You can see this small topic. Solute plus solvent gives you the solution. Fine. Here there are two components. One is solute and the other one is solvent. What is the solute? Salt. What is the solvent? Water. If two components are present in a solution, we call it as a binary solution. Now I have one more substance called sugar. I've already added salt to this. I'm adding sugar and I'm stirring it up. What happens to the sugar? Sugar also got dissolved. So there are three components in this solution. One is salt, the other one is sugar, and the other one is solvent. If two or more solutes are dissolved in a solvent, and we call it as a ternary solution. A solution, and we are talking about mixture, homogeneous mixture, heterogeneous mixture, and this is an example for homogeneous. Salt plus water cannot be separated, and this is heterogeneous mixture. An example for that, sand and water, this can be separated by filtration. And homogeneous mixtures, they are called solutions. And we were talking about the components. This is solute, component which is present in lesser amount by weight is called solute. And what is solvent? As I already told you, substance which is present in larger amount by weight is called as a solvent. And together, solute plus solvent gives you the solution. And one more term I'm introducing here, the process of uniform distribution of solute into the solvent is called dissolution. And binary solution. What is called binary solution? Solution with at least two components. So that means one solute and one solvent. They're called binary solutions. And you have ternary solutions. What do you mean by ternary solutions? Two solutes dissolved in a solvent. For example, water plus salt plus sugar. Solutions with three components are called as ternary solutions. Now we are going to see about the types of solutions. Solutions are classified based on few parameters. First, we are going to see how a solution is classified based on the nature of the solute and the solvent. Normally, the substances are classified into three types, as you know, variable, solids, liquids, and gases. The substance which is present in larger amount is always called as the solvent. We have learnt it. Now, the physical state of is a primary factor which determines the characteristics of the solutions. I've got few examples. You can view it right now. And the first category, this is solute, this is solvent, and this is example. These are based on the physical states. And if the solute, both the solute and the solvent are in the form of solid and solid, very good example is copper dissolved in gold. Otherwise we call it as an alloy. Here the solute is liquid, but the solvent is solid. The major portion is solid. The example is given here, mercury with sodium. Next one is the solute is solid and the solvent is liquid. The liquid is the major portion. So this is sodium chloride in water. The next thing is both the solute and the solvent is in the liquid state, and you can see the example ethyl alcohol in water. The next category is the solute is gas and the solvent is liquid. So this is a CO2 in water, carbon dioxide in water. The other category is the solute is in the liquid form and the solvent is in the gaseous form. So this is what example is water vapor and air, and both the solute and the solvent are gases. The example is mixture of helium and oxygen gas. Yes, based on the type of solvent. Suppose if I use water as a solvent, and it is called as an aqueous solution. If I use any other liquid other than water as solvent, it is called as a non-aqueous solution. An example, salt in water or sugar in water. Here we can see sulfur dissolved in carbon disulfide or iodine dissolved in carbon tetrachloride. Yes, now we are going to move on to the other type of classification. Solutions are classified based on the type of the solvent we use. Here I have with me a cup of water in a glass. Here I've taken water as the solvent. For example, if I take water as the solvent, and that type of solution is called as an aqueous solution. For example, if I don't take water as a solvent, if I take benzene or alcohol or ethers or carbon disulfide as solvents, and that type of solution is called as non-aqueous solution. I'll repeat. If I take water as the solvent, it is called as an aqueous solution. If I take other solvents other than water, for example benzenes and ethers and carbon disulfide, that type of solution is called as non-aqueous solutions. The third type of the classification of the solutions is based on the amount of the solute particles. Based on the solute particles, the solutions are classified into another subdivisions. One is saturated solution, the other one is unsaturated solution, and the other one is super saturated solution. I'm going to give the names of it. You can just see based on the amount of solute. One is saturated solution, the other one is unsaturated solution, the other one is super saturated solution. The third type of the classification of the solutions is based on the amount of the solute particles. Based on the solute particles, the solutions are classified into another subdivisions. One is saturated solution, the other one is unsaturated solution, and the other one is super saturated solution. I'm going to give the names of it. You can just see based on the amount of solute. One is saturated solution, the other one is unsaturated solution, the other one is super saturated solution. Now we are going to see what is called the saturated solution. Saturated solution is nothing but no more solute can be added to a definite amount of the solvent at a given condition. I am going to explain what is called a saturated solution. Consider this as 100 gram of water taken in a glass, and I have salt with me. So I am taking, for example, 1 gram of salt, dropping in the water, stirring it up, and what happened to the salt? Got dissolved. Now I am adding 1 more gram. I am stirring it up and keep on adding 1, 2, 3, 4, 5, 6, 7, 8, 20, 21, 30, 31 grams, 32 grams, 33 grams, 34th gram. Now I'm getting 35th gram of the salt, and imagine that I'm stirring it up, and what happened? Imagine got dissolved. Now I am adding the 36th gram of salt into the 100 gram of water, and what happens? The salt does not get dissolved. This condition is called as the saturated solution. Now I have in front of me the saturated solution. Earlier we have discussed what is a saturated solution. 36 grams of sodium chloride, when dissolved in 100 grams of water, the salt did not get dissolved. That condition is called the saturated solution. Now when suppose I heat this solution, what happens? There's a condition, or there is a space to add some more salt to the solution. That condition is called as the super saturated solution. So when you change the temperature, you're able to add some more salt to the saturated solution. So that condition is called as the super saturated solution. I'm going to show you a flow chart on the amount of solute. So this is unsaturated solution. So solution contains less solute than of the saturated solution at a given temperature. That is up to 35th gram. Here we have taken as 30 grams or 20 grams or even 1 gram sodium chloride in 100 grams of water at 25 degrees Celsius. I will move on to saturated solution. Here we have added 36 grams of sodium chloride in 100 grams of water. We cannot add more solute to this solution. No more solute can be dissolved in a definite amount of solvent, so that is called as saturated. And what is called super saturated, and when we change the solution contains more solute than the saturated solution at given temperature, so that condition we call this as super saturated solution. Next is the other classification of solution. This is called as the concentrated and dilute solution. It is another kind of classification of unsaturated solution. It expresses the relative concentrations of two solutions with respect to the solutes present in the given amount of the solvent. For example, you order 2 cups of tea in a tea shop. 1 cup is added with more amount of sugar and the other cup is added with lesser amount of sugar. And which one will you call it as a concentrated one? The cup of tea which has more sugar, isn't it? When we compare two having same solute and solvent in a solution, the one which contains higher amount of solute per given amount of the solvent is said to be a concentrated solution, and the another is said to be the diluted solution or the dilute solution.